Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, dear students. Welcome back to this TV Learning Series program. I'm Teacher Patrick, and I'm so excited to be with you once again as we've been together. Today, we are going to look at, we are still on Unit 5. By the way, I will be with Senior 6. And we are still on Unit 5. We'll be looking at the derivatives of the benzene. You remember we had looked at some of the derivatives of the benzene. If you remember, we looked at the methyl benzene as one of the derivatives. And we look at the lesson of today. We'll just look at the uses, we'll look at the physical properties, we'll look at the nomenclature and some preparation methods of phenol. The preparation methods of phenol. I think we'll have to add that one there. So because that is what we are looking at today. But before we look at this, I would like us to just take a look at some of the things that we looked at in the previous lesson. You remember we looked at the methyl benzene. And let's look at this and see whether we can still recall what we looked at in the previous lesson. The revision is on, this question is about chlorine reacts with methyl benzene under two conditions. Two conditions. So we need to state the conditions. We write equations to show the products of the reactions above. That is the reactions. We are in the two reactions here. And then we'll suggest the mechanism for each reaction indicated, and then state the names of mechanism in each case. I urge you to pick your books and your pens, and try to write it down. We just go through together. I'll just give you some few seconds to do that one. I hope you are doing so. So let's work it out together and see. So you'll be comparing with what you are getting and what I'm just going to put on the blackboard here. So the two conditions, one of the conditions, you remember we said it reacts with sunlight. The condition is sunlight when it reacts with chlorine in presence, or we said this one can also be as indicated as UV. That is, if you remember the methyl, we called it the side chain reactions of methyl benzene. So this is one of the conditions, and we said there are two conditions. So it reacts with chlorine in presence of either catalyst, and if you remember, the catalysts are very many. We said in this case, a catalyst must be a Lewis acid. A Lewis acid, and we gave some examples. Do you remember some of these examples that we gave? One of them is aluminum chloride, or the chlorides or the halides of aluminum. We have iron 3 bromide or iron 3 chloride, and so on. These are some of the examples of the catalysts that we use. So, and we said there must be Lewis acid. So these are the two conditions: in presence of sunlight and in presence of a catalyst, which must be a Lewis acid. It must be a Lewis acid. So those are the two conditions. Write equations to show the products of the reactions. So when you write the equations, it will give you the products of the reactions. So let's write those equations and see whether we can be able to get those products of the reactions. So one of the reactions, we have methyl benzene. Remember we said this is a side chain. When it reacts with chlorine in presence of UV, that is sunlight, we said there will be substitution still on the benzene, on the methyl group on the benzene ring. So the substitution takes place here. So this reaction is continuous, as similar to that reaction we looked at in alkanes, if you remember, the way it reacts with chlorine. The above, that is one of the reaction. We are supposed to indicate the product. This is the main product. We say the right equation to show the products of the reaction. So this is one of the products of the reaction when it reacts with chlorine. So another one would be, this is methyl benzene, and then it reacts with chlorine, this time in presence of aluminum chloride as a catalyst, which is acting as a Lewis acid, and then it produces. So this is another reaction. So this one produces plus hydrochloric acid. So this is a substitution reaction. So substitution in the ring. So it will be electrophilic substitution in the ring. So these are two different. So depending on the conditions that are used, we are using ultraviolet rays or ultraviolet light. There will be side chain substitution. When we have no, there will be now we said this is side chain reactions, whereby the chlorine substitutes the hydrogen of the methyl group that is attached on the methyl benzene. So when it comes to, when we have chlorine can also again react with methyl benzene in presence of aluminum chloride as a catalyst, and we said this is substitution in the ring, not on the side chain. So that is what we talked about. Those are the products, the two. This is chloromethyl benzene, and then 2-chloromethyl benzene. So we have part C. Suggest the mechanism for each reaction. So we'll start with the first one. So this is part A, this is part B. So the part B, sorry. So we'll go to part C. Suggest the mechanism for each reaction. We need to suggest the mechanism. So even before we suggest the mechanism, they say state the names of the mechanism. So if you can be able to state the name of the mechanism, then that means you still remember the type of the mechanism. So that is, this one is free radical substitution. So that means I'm answering part D before we reach there. Free radical substitution. The same mechanism as it is undergone by the alkenes. So this is, we said this reaction, the free radical substitution, takes place in 3 steps. You remember there is initiation, there is a propagation, and then there is termination. So we start with the initiation, where the chlorine molecules, the bonds break. So these bonds are breaking homolytically. So the bonds are breaking homolytically. So we call it homolytic fission. So the chlorine bonds, these bonds are breaking equally. And that one, the UV, that UV, that is form of energy, is the one that that is used to break this bond between chlorine and between the chlorine molecules. And then it will form 2 chloride radicals. Radicals are free. They are free radicals. They contain unpaired electrons, and they are very reactive molecules. So what happens in the next step, that is, we go to the propagation step. So in the propagation step, the radical now removes 1 hydrogen from the methyl group, and that means it will form CH2. This is the methyl, this is the benzene ring. This is the radical, plus the hydrogen chloride. So it has substituted the hydrogen here. One hydrogen has been removed. So this radical now combines with more other chlorine molecules. So this is hydrogen chloride. So you'll have this radical, now this one that has been formed, with the CH2, this is a radical, and now this one combines with another chlorine molecule, and then it will form CH2 with chlorine, plus the radical being regenerated, and then forms that compound. So this is the first compound that is formed. So this is step number 1, this is step number 2, and this is step number 3. So this step number 2 and number 3 are repeated several times until all the hydrogens have been substituted, and then you'll have, when step number 2 and 3 are repeated, then you'll have these two products forming. You'll have this product forming, chlorine, and you'll have, and this is another product that will be formed as a result of repetition of step number 2 and step number 3. That is how it takes place. This is free radical substitution. I'm even answering part D of the question. Free radical substitution. So the second reaction, we had looked at this one even before. If you remember, we looked at this mechanism. The other time we never looked at this mechanism, but this one we had looked at it even before when we were looking at the same reactions undergone by the benzene. You remember we said this methyl group is electron donating. It has positive inductive effect, and then it directs other substituents that are coming to position number 2 and number 4. Actually, in this reaction, you have two products, two main products that are being formed. So we have this one on position number 2, and then you can have another product, which will be with chlorine attached. So you have 2-chloromethylbenzene, or 2-chloro-taurine, and 4-chloromethylbenzene. So these are the two products that are mainly formed. Why? Because this methyl group is electron donating. It increases the reactivity of the benzene ring and then directs other substituents to position number 2 and position number 4. So let's now continue and look at the sum of the uses, because we are looking at the phenol this time. We are looking at the phenol. This is another derivative of the benzene, phenol, which is written in that form. So it can also be written in this form. If it can also be you can write it in this form with OH. So that means it has the OH group attached on the benzene ring. That compound is called phenol. Phenols are widely used for the antiseptic and the disinfectant properties. When we talk about the antiseptic have the ability to arrest the development and growth of the bacteria. So it actually reduces the growth of the bacteria or the microorganisms that may even attack our bodies. And they are also used as antioxidants. What do we mean by the antioxidants? These are substances that reduce or delay the damage of our cells. Antioxidants. So these antioxidants, our bodies also produce antioxidants. The immune cells within our bodies So, these antioxidants are also produced within our bodies. And then they are the ones that are responsible for the delay of damage of the cells. What causes the damage of the cells? There are various substances which we call free radicals. These free radicals are also being produced within our bodies. And what causes this formation of the free radicals? These free radicals are either caused by either the type of the foods that we eat, or they are caused by the other pollution substances outside, cigarette smoking. You can even talk about even the large intake or excessive intake of the alcohol can cause even those free radicals in our bodies that destroy the cells. So, but these substances, the antioxidants, are produced to counteract the effect of those free radicals. We can get them from fruits like vitamin C. We can get them from vitamin E. So from different sources of the foods. And it delays even. So when these free radicals outnumber the antioxidants, what happens? We call it oxidative stress. And the oxidative stress will damage the DNA. When the DNA is damaged, a lot of problems, the cancers and so on and so forth. So those are some of the uses. We are indicating some of the compounds of phenol, with some uses. We have, this is 2-chlorophenol. It is used as a disinfectant. This is 4-hydroxyphenol, which is commonly known as hydroquinone. This one is used in photographic developers. And then we have 4-hexylphenol. This is a germicide in soap. So it is added. Germicide, that means it kills germs, and it is added in soap. This is 2-phenylphenol. This is also a disinfectant spray. And then we have butyrated hydroxymethylbenzene. This is an antioxidant in butter and even added in chewing gum. So it is added there. I've talked about the purpose of these antioxidants, to delay the damage of our cells. We can even continue and look at the physical properties. One of the physical properties is that this phenol is a colorless crystalline solid. Colorless crystalline solid. I'll just have to show you this colorless crystalline solid. Do they look colorless? So this is phenol. When you look at it, it doesn't look colorless. It is turning to, when you look at it, it's turning to pink. It is colorless, but it slowly turns to pink when it is exposed to air due to complex oxidative products. So it is turning to pink, as you can see. That is one of the physical properties of the phenol compound. So it melts at 42 and boils at 100. Strong smell of disinfectant. It has a very strong smell. You know how disinfectants smell. And then when exposed to air, I've talked about that. You look at the color changing to pink. That is due to the oxidation and formation of the complex products. It forms hydrogen bonds with water. So substances that form hydrogen bonds with water are supposed to dissolve in water. Let's see whether it dissolves in water. This is the water we just brought here. And then we add some water. Does it dissolve in the same way as other alcohols do? No, it doesn't. The solubility reduces, but it is fairly soluble. It is understandable because it forms the hydrogen bonds. It is dissolving. But even when you look at it slowly, when you look at it keenly, you see it doesn't dissolve as faster as the alcohols. We had seen even some alcohols. Why is it not stronger? Yet we have said it forms hydrogen bonds with water, but it doesn't dissolve completely or similarly to other alcohols. So they reduced because of the benzene. This benzene ring here that we are looking at increases the carbon content. And if you remember what we talked about in the physical properties of the alcohols, we said that the solubility decreases as the number of carbon atoms increase. Solubility decreases as the number of carbon atoms increase. Why? So as the number of carbon atoms increase, you will have the intermolecular forces, the actually we talk about the van der Waals forces, now outweighing the hydrogen bonding. And that means that reduces the solubility. Here, we talk about the hydrogen bonds, but its solubility is reduced due to the hydrophobic. Hydrophobic means water, hydro means water, and phobic means heating. So hydro, water, phobic heating. So that's hydrophobic heating. This ring here is non-polar, and therefore it heats the water. So because of the large number of the carbon content in benzene, that reduces its solubility in water. But when warmed up to temperatures slightly above 66 degrees Celsius, it becomes completely soluble in water. So we can look at some of the phenol compounds. We had even mentioned, we had even talked about this. This is phenol, and we said because the phenol, the compounds that have OH, which if it is a benzene, so it takes all the names, all the compounds will be based on this one. So these others will be substituents. That's why we call it 2-chlorophenol. So the naming will be based on this one. 2,4, that is position number 2 and 4. They are chlorine, phenol. And then you have 2,4,6 trichloro. This is 1. That is 4, and that is 6, as you are numbering those carbon atoms in the ring. So 4-chloro, 3-ethyl dimethyl phenol. So here, they are different substituents. So what happens? You need to put them in the alphabetical order. So the alphabetical order is that the chlorine comes before the methyl. So you have to arrange them in the alphabetical order. So that's why chlorine comes first. And we say 4-chloro. Then as you move, because this one must be the OH, or that phenol, or that OH must be on position number 1. So it goes, and therefore as you're moving, you're counting from this to this direction. So you have the methyl on carbon number, this is number 1, number 2, this is carbon number 3, so this is carbon number 4. So that's where we have 4-chloro, because it is on carbon number 4. And then we have 3, the methyl group is on carbon number 3 and number 5, dimethyl phenol. This is commonly known as ditto. Ditto, I think you have even seen some of the detergents, some of the soaps is named as ditto. That is, ditto is the industrial name. So that is why we have that as ditto. This is the chemical name. So we can probably also look at the preparation methods. How is the phenol prepared? Phenol is prepared through different methods. The first method is preparing from haloallenes. Allenes are aromatic compounds of the benzene. So this is haloallene, haloallenes, that is halogen attached on the benzene ring. So it will be benzene, rather chlorobenzene, sodium hydroxide under those temperatures will be able to produce this intermediate compound, and then in presence of water, it will produce the phenol as they want. So we can prepare even benzene, or rather phenol, from benzene sulfonic acid. This benzene sulfonic acid, But benzene sulfonic acid is prepared from benzene. So starting from benzene, then we prepare benzene sulfonic acid, then we add sodium hydroxide, and in presence of the acid, then we'll be able to produce the phenol that is needed. Another method that is commonly used is from diazonium salts. We'll look at the diazonium salts later on when we look at the amines. Diazonium salts are prepared when the amines reacts with the hydrochloric acid and then produce, this is the benzene diazonium salt. In presence of water, they are very reactive molecules. In presence of water, they will produce phenol or hydroxybenzene. So from cumin, the cumin is isopropyl benzene. That is the chemical name. This is the industrial name. So isopropyl benzene can also be used when it is oxidized, and then the product is added into the acid, then we'll get phenol as one of the products that can also be used. It can also be prepared from a Grignard reagent. Maybe this can be number 5. If you have a Grignard reagents, you remember we talked about these Grignard reagents. In presence of ether, this one will produce which reacts with water. In presence of water, this one will change into the phenol. So that is another product that can be used to prepare also phenol. So this is what we are supposed to look at. We are supposed to look at the uses. We have seen some of the uses as disinfectants and as antioxidants, if you remember, main uses. So we have said these antioxidants can also be obtained from foods that we eat, especially the vitamin C, food like fruits, vitamin E, as one of the examples of those antioxidants. But we said even antioxidants, our bodies produce them. And then we said, what is the purpose of these antioxidants? We said they are supposed to delay the damage of the cells. And what causes the damage? We said the free radical substances that are continuously being produced within our body. So what are these? What do they? Those free radical substances are the ones responsible for destruction of the cells. Even the DNA, which we said when those free radicals outnumber the antioxidants in our bodies, then the DNA can be destroyed. That can lead to the cancer and even the aging. That one, you'll talk about it in details when you are talking about, when you are in DNA structure and chromosomes and whatever. So this is what we are supposed to look at, even the physical properties. So with that, I hope you've been with me. I thank you so much for being with me. And I hope to see you in the next lesson. Bye-bye.